So if you guys are using your time wisely, you typically have 30 minutes in class to work on homework. You should be able to finish your paper assignments in class and then work on your Delta Maths at home. All right. So we got to do our homework. Okay. So today we're going to start talking about linear inequalities. Linear inequalities. We're going to graph linear inequalities. Thank you, ma'am. So we have to think about what the symbols represent. And because we're going to turn our inequality into a line, it's going to have two variables, x and y. We're going to try to write everything in y equals. So we're going to put everything in slope-intercept form, but instead of an equal sign, we're going to use an inequality, okay? So the greater than symbol, I'm going to write greater than, is going to produce a dashed line. The greater than symbol is going to produce a dashed line. And it says y is greater than everything else. So y is the vertical up and down axis, right? So when you think about like how this looks, if you think about shading, if I were to say I have this line and it goes just like this, right? It's a dashed line. And it says y is greater than everything that this line represents. Am I going to shade above the line or below it? My y values are right here. Y is greater than everything that the line represents. Am I going to shade above it or below it? Above. So that's what you're going to put under the shading. Above. Shade above. Okay, let's look at our next one. This is greater than or equal to. So this is not going to be a dashed line because it includes everything on the line. It includes everything on the line. So this line is going to be solid. But we're still going to shade above. So I want you to think back when you learned how to graph inequalities. If you had a greater than symbol, it was an open circle. If you had a greater than or equal to, it was a closed circle. So that open circle linearly represents a dashed line. That closed circle linearly represents a solid line. That's where this comes from, okay? This next symbol is less than. This is just the less than symbol. So less than is not equal to, right? So it's going to be a dashed line. Doesn't include the line. Just it makes the boundary. But the y values are less than our line, so we're going to shade below. Less than or equal to. It's going to be a solid line, and we're going to shade below. And again, I'm going to show you, like, if you were to graph this as an linear, like just one variable term, you would be an open circle on the less than, and then less than or equal to. Oh my goodness, that's not what I wanted. Less than or equal to, you would give it a filled in circle, a closed circle. This line right here means equal. It's telling you that you need a solid line or a closed circle. So we're going to graph linear inequalities. We're going to graph them all in the form. All of our equations we're going to write in this form. Y equals mx plus b. The only difference is that our equal sign is actually going to be an inequality. Okay? Seamus, pick your head up. It's not nap time. Okay. So let's look at example number 1. Example number 1, I have y is less than 3/4 x minus 3. So tell me what my slope is. 3/4. What is my y-intercept? -3. Look at the symbol. Does the symbol less than produce a solid or a dashed line? Dashed, so just circle dashed. And does the symbol less than mean I shade above or below? Below, it's less than. So let's go ahead and graph that. When I graph y equals mx plus b, where do I begin? I begin at -3. I begin on the y-intercept. So 1, 2, -3. And then I have a slope of 3/4. That means I go up 3, to the right 4. I'm going to do that one more time. Up 1, 2, 3, to the right 1, 2, 3, 4. I go off my graph one grid. And then I'm going to go down 3 and to the left 4. And the reason I do that multiple times is because I want a dashed line. So I just kind of put little dashes in between all my points. Okay. Put little dashes in there. So we have to shade the solution set. And remember that the solution is everything that is all of the y values that are below your boundary line. All of the y values below your boundary line. So the solution is any number that lies in this region. Any number that lies in this region. Okay. If you guys want highlighters, raise your hand and I'll make sure we get some highlighters up there to be your shades, to be your shading list. Highlight to shade, anyone? Anyone else want a highlighter to do their shading? I toss it to you, Ashley. You're right. Did you have your hand up? No. Okay, I'm gonna leave them right here. If you want a highlighter, help yourself. So it says, what is the solution to this inequality? And because it's a line, it's a linear function, it means the solution is gonna be an ordered pair. So a solution is any number, any ordered pair that lives in that shaded region. So Cameron, pick one ordered pair in the shaded region. Tell me one ordered pair in there. In the shaded area. 4, -2. Perfect. That's one answer. 4, -2. Oh, that looks awful. Hang on a second. 4, -2. Okay. Someone else, give me a solution in our shaded region. What do you got, Uriah? 5, -5. Yep. Someone else. 5, -3. Yeah. Do you guys understand how this works? How do we know that we did this correctly? How could we check this? Well, let's take the first solution that we were given. The first solution that we were given from Cameron was 4, -2. God bless you. Remember that this is the X and this is the Y. Okay. So Y, I'm going to replace the Y with -2, is less than or equal to 3/4 times X, and my X value is 4, minus 3. Well, let's see, -2 is less than or equal to 3/4 of 4 is 3. 3 minus 3 is what? Is -2 less than or equal to 0? Oh, less than symbol. Sorry. Where did I grab that equal to? Sorry about that. Thank you, hon. It's just going to be less than. So yeah, it's less than, -2 is less than 0. Okay. -2 is less than 0. So you could check it, right, to make sure that your solution works. But that's what we're going to do. We're still graphing y equals mx plus b, but it's got a twist because there's an inequality. Okay. Raise your hand if you need me to keep this up there for a second. Okay, move on to the next one. Okay. So example number 2, y is greater than or equal to -1/3 x plus 4. Aiden, what is my slope? Yes, sir, -1/3. Lorenzo, what is my y-intercept? 4. All right, looking at the symbol, Justice, when you look at the symbol, greater than or equal to, is that going to provide us with a dashed line or a solid line? Greater than or equal to. When you look at this inequality symbol right here. Solid, good job. Circle the solid. It's greater than, Hayden, I see your hand up. Are you stretching? A hand and a stretch? Are you going to shade above or below? Above. Okay. Carla, can I call on you? Where are we going to begin? Where do we start our graph? The y-intercept at +4. 1, 2, 3, 4. Sebastian, what is our slope? So I'm going to go what direction? Up or down? It is negative. So I'm going to go down 1 and to the right 3. Down 1 and to the right 3. I'm also going to go up 1 and to the left 3. Connect my points with a solid line. Connect my points with a solid line. How am I shading? Above or below? Above. Shade above. So let's talk about solutions to this. Can someone name a solution to this inequality? Say again. Ordered pair 1, 5. Okay. What about the ordered pair 3, 3? Is that a solution? Do you guys see how 3, 3 is right on the line? It would. Very good. So solid line means that points on the line are solutions. But just like Aiden said, if it's a dashed line, points on the dashed line are not solutions because that boundary says it's not including, right? It's not including that boundary line. Okay. Are we getting it? Making sense? Okay. We have 2 more. So number 3. We'll do number 3 together, and then I'm going to freeze the screen and let you guys do number 4. Number 3, Brian, what is my slope? Perfect, 3/5. Seamus, what is my y-intercept? 1. Zan, my inequality less than tells me I'm going to have a solid or a dashed line. A dashed line. The only time you have a solid line if it has the bar underneath it, okay? Am I going to shade above or below, Amalia? Good job. Below. All right. So, Jaden, where do I begin? Begin at 1 on the y-axis. I go up 1, 2, 3 over 1, 2, 3, 4, 5. I can also go down 3, 1, 2, 3, and to the left 5. Okay. Remember that my line is dashed. So I just do my very best to kind of give myself a dashed boundary line. Am I going to shade above or below on this one? Below. Shading below. Okay, inequality. Give me a solution to the inequality. Tell me one point that works, Uriah. -1. -4, +3 is going to be up here. How about +4, -3? Will that work? Okay, so 4, -3. Bailey, give me another solution. Pick a point anywhere in your shaded region. Say again. Are you saying 3, -2? Because you're talking so softly, I can't hear you. Yes? Okay, 3, -2. You guys get that? Does it make sense how to find your solutions? Okay. I'm going to freeze the screen, and you guys do number 4. You do number 4. It's not written in the right order. That's your hint. You have to change the order a little bit. Same steps. Identify your slope. Identify your y-intercept. Look at the inequality. Are you shading above, below, solid, or dashed? Everyone should be able to do this. Everyone should be able to do this. So how should that equation be written, or that inequality be written, if it's in y equals mx plus b? What form what do I have to change around? Y equals x plus negative. Yeah, it needs to be y equals x minus 3. That's the first thing I need to do. I need to write it as y equals x minus 3. Or y is less than, sorry, x minus 3. And then I need to find my slope. Well, the number attached to the x is 1, and the y-intercept is -3. Symbol less than means it's going to be a dashed line, and I'm shading below. So I'm going to begin at -3, and I have a slope of 1. I make a dashed line. I said that my solution is 3, -3. Some of you guys had horizontal lines, and some of you guys had your slope going the other way. Take a look at that. I'm going to leave that there for a second so you can get it graphed. Yes. Yep. Up 1 to the right one. Up 1 to the right one. All right. We have 2 more questions to do. Here's what we're going to do. If you like sports, you're going to do number 5. If you like sports, you're going to do number 5. If you don't care for sports, you're going to do number 6. Notice that both of those are not written in the right form. What do you have to do with those? What are you going to have to do with those? You're going to have to make them look like this. Okay? You're going to have to solve for y on both of those. Yep. Not yet. You got to wait till instruction's done. solve for y. So if you think about it, this is your and then the number attached to it. Number 5 is easier than number 6. If you're doing number 6, watch out for that negative. Watch out for that negative. Your slope is not -4 when you solve for y. Let me look. Yeah, you want to make it look like y equals. So for number 6, you're going to subtract 4x from both sides. And then you have to divide by -2. Remember what happens when you divide by a negative. Remember what happens when you divide by a negative. Maybe I should just do it with you. Let's look at number 5. Let's do this one together. If I'm trying to get y all by itself, the first thing I'm going to do is add 4x to both sides. Add 4x, add 4x. That gives me 4y is less than 4x plus 8. Then I'm dividing everything by the number attached to the y, which is 4. Y is less than x plus 2. So my slope is 1, and my y-intercept is 2. When I look at number 6, I have to subtract 4x from both sides. And when I do that, I have -2y is greater than or equal to -4x minus 12. But I have to solve by dividing by a negative. And remember, when you divide by a negative, you have to flip your inequality, right? So y is less than or equal to a negative divided by a negative is a positive 2x plus 6. So my slope is 2, and my y-intercept is 6. Okay?